Hello and welcome back to the second part of the 1-6 video. Today we're going to be looking at displaying data. To begin with, we're going to look at what we call a frequency table. This is a type of table that's going to show data and how often the data occurs. So if we look at this example here, it says a number cube was rolled 20 times, the results are at the right. Display the table in a frequency table, then make a line plot. So our data is over here, so it looks like we rolled a 5, a 2, a 5, a 4, a 1, a 6, and so on. So what you need to do with this is you need to, by creating a frequency table, this right here is going to be our frequency, or the number that got rolled. Then this right here is our frequency. So you can either tally it up if you want, or you can just go ahead and count. So let's look at, just to see how this works, the number 1. Okay, so if I come over here, I can see I have 1, 2, 3. So I have a frequency of 3 for the number 1s that were rolled. If we look at the number 2s that were rolled, we've got 1, 2, and it looks like that was it. So that shows up here. For the number 3, we can see that we have nothing in the top row, and then I have 1, 2, 3, 4, which occurs here, and you would do that for every number on that die. Then what you could do is you could go and put this data into a line plot, which we'll talk about here in a little bit. For right now, though, since we're talking about frequency tables, we also have something called a two-way frequency table. Now, a two-way frequency table shows the possible relationships for two pieces of data that are kind of similar. A lot of times it's used to show survey results. So this here is an example of a two-way frequency table. So you can see it says a survey was asked if you could have a new vehicle, would you want a sports utility vehicle or a sports car? So you can see they have their sport or SUV ultimately, and their sports car data right here in these two columns. However, they also broke their data down into male and female. So if I read this table, for my sport utility vehicles, I can see that there were a total of 156 people that wanted an SUV, and the breakdown of those for male and female is 21 males wanted an SUV and 135 females wanted this. Likewise, with the sports car, we have 39 males that wanted the sports car and only 45 females that wanted that. Now notice that if I take these two boxes here and add them up, I get my 156. Likewise, if I take these two numbers here and add them up, I get 84. So I can see that I have a total of 156 people that want the SUV and 84 that want the sports car. Now, if I add these two boxes across into the row, I can see that a total of 240 people were surveyed. Likewise, if I want to know how many males were surveyed in all, I can go horizontally here and add up these numbers. So I have 21 plus 39, which will give me 60 males were surveyed. And I have 135 plus 45. This will give me 180 females were surveyed. And again, if I add these two numbers here, the males plus the females, it should also give me this total down here. So this is kind of how you set up a two-way frequency table. And just note that when you're looking at the frequency tables, there's two different types of numbers you can look at. You can look at the relative frequency, which compares the desired quantity to the total number of respondents. So we could have said that how many females wanted a SUV compared to the total of 240 people that were surveyed. Or we have what we call a conditional frequency, and this compares the desired quantity to the total number of respondents from a row or column. So this would be like me saying from that previous example of the total number of females that were surveyed, how many wanted the SUV. So I totally ignore like the male data information for the conditional frequency. Next, we have what we call line plots. Line plots allow us to see the frequency of data items and compare the data items. So here we have an example of a line plot, okay? And you can see all these little X's down here, sometimes they use dots, shows the frequency of that number occurring. So here it looks like we have heights in inches of 25 adults. So at a quick glance, I can see that this number here has the most X's, and that looks like that has a height of 67 inches. Likewise, I can see my outliers. Okay, I have somebody that was 77 inches way out here, and I also had somebody that was 59 inches way down here. So this is just a way to kind of show at a quick glance all of this information right here. We have bar graphs, which help us compare amounts. We have typically we have categories on the x-axis, and you can put them on the y-axis too, but I think a lot of times they just occur on the x-axis or horizontal axis. We're going to put our numerical amounts on the vertical axis. You'll see there should be a title. Usually we should have a label for each axis and a key if you have multiple bar graphs. So this here is an example of a bar graph. Notice that my text titles are down here at the bottom, so it looks like we're comparing the number of people to the types of fruit that maybe they like or they find the nicest. Okay, again, at a quick glance, I can see that people really seem to like the blueberries, and probably apples aren't too far behind that. Now in this example of a bar graph, again, we have our word data. So in this case, we're looking at different states that run along the horizontal or x-axis, and our numerical data is being measured along the y-axis. Now here we have our standards like our title, we have our x and y axis information, but here they do give us a little key, and this key tells us what each of the different colors means on this chart here. So I can see that anytime I see a pink bar, that's for the year 1995. The bluish color is 1997, and the greenish color is for data in the year of 1999. Now, we also have what we call a histogram, which kind of looks like a bar graph, but a histogram is going to show us the frequency. Okay, and the key thing with a histogram is you have to have equal intervals on the horizontal axis, and there is not to be any gaps in between the bars. So notice here we have our vertical bars in this case. They all touch, and if you notice our x-axis down here, we have our equal intervals. Like I can see that each width goes up by an increment. There's a width of 50 here, there's a width of 50 here, a width of 50 here, width of 50, and a width of 50. So these are all equal increments across each individual bar. Likewise, if you look at this one, we notice the same things. Okay, we have our title, we have our horizontal axis labeled, our vertical axis labeled. The horizontal axis goes up. In this case, it looks like we're going up in increments of 5. The graph, all of the bars touch each other without having any spaces. So these are just kind of some typical components of a histogram. So to create a histogram, a lot of times what you have to do is you have to decide first and foremost what your interval is. So I like to go and find the minimum and the maximum numbers. So looking at my data here, it looks like the number 9 is my smallest number, and the number, what do we have? It looks like 22 might be my largest number. Now I have to decide what is the best interval going to be to show my data. Now you could go up by 2s, but looking at the data that I have here, I might kind of have some gaps. If I go up by 2s, you could do maybe 3s or 4s, okay? And it really doesn't matter. So what I'm going to do here is I'm going to just, I'll probably go up by increments of 4. So for my frequency table, so my interval I'm going to say that this will be in groups of 4. So I'm going to look at 0 to 4. Then I'm going to do 5 to 8. I'm going to look at 9 to 12. 13 to 16. I'm going to slide this up here. Then we'll do 17 to 20 and 21 to 24. So in my frequency, I just have to make sure that my ending frequency at least captures my highest number. So now I'm going to go and find my frequencies. So this right here is my interval. Now this is the frequency that occurs in. So I have no data in the 0 to 4. In the 5 to 8, I also have no data. But now in the 9 to 12, I have the number 9. So I have 1. I have 10 falls in that range. Another 10, an 11, a 10, and another 10. So if I add these up, I have 1, 2, 3, 4, 5, 6. So I end up with 6 numbers that fall in the 9 to 12 range. Then in the 13 to 16, oops, and sorry, I did miss one here. I missed the very first number there, which was 12, so that would bump me up to 7. Then in the 13 to 16 range, I can see that we have 14 and 14, so that's going to give me 2. I have 1 in the range of 17 to 20, and then I have 21 and 22 here, so I have a frequency of 2 for the 21 to 24 range. So then if you go in and you draw your histogram, you're going to have to incorporate all of these intervals here. So maybe I go 4, 8, 12, 16, 20, and 24. So I do not have anything in the 0 to 4 range here. Likewise for the 5 to 8, but I'm going to go up to 7 on my 9 to 12. So I need to put a label on my y-axis. So here I have 1, 2, 3, 4, 5, 6, 7, 8. That's an 8 there. So now if I go and I plot this, I have a frequency of 7 in the 9 to 12. So 7 is going to look something like this. And then in the 13 to 16, we have 2. So that's going to be down here. In the 17 to 20, we have 1. And then in the 21 to 24, we also have 2. So this right here, and if you wanted to color these in, you can, just to see. Then you would label your X and your Y axis and put a title on your graph as well. Now sometimes we're going to encounter line graphs. Line graphs are nice to show change in data over a given time. And we a lot of times will use these to look for trends and make predictions. So here's an example of snowfall for Michigan from 1910 to 2013. Okay, and you can see that they have the year 2030 here. So maybe if they went and they were to kind of extend this line some, they could make a slight prediction. Okay, maybe you guys should try that and come back and check this in about 10 years. But your line graph has a title, an y-axis, and an x-axis as well. We have pie charts or circle graphs. This is typically used to show percent or fractions of a whole. So all of the numbers in the pie chart needs to equal 100% or 1. And here you can see we have 2 different ones. So for this graph here, it looks like we have pepperoni is the largest percentage of favorite toppings. Likewise, people seem to like supreme, the least amount. If we come over here for the school lunch, we can see that pizza definitely is the most well-liked school lunch, as to where maybe the chicken sandwich and the tacos are probably the least favorite down here. Now the last type of graph that we're going to look at is what we call a box and whisker plot. Now box and whisker plots are used to show how data are spread out. Okay, and it includes features such as your min, your maximum values, the medians, and what we call lower quartiles and upper quartiles. And these are nothing more than certain types of medians as well. So this is also a median values. Okay, and I'll show you how to find these here in just one moment. Now this is what a box and whisker plot is going to look like. You can see you have the box in the middle, and then you have these two whiskers here. So when you are creating a box and whisker graph, the first thing you're going to do is I usually start out by plotting my minimum and my maximum values on a line graph. And then you're going to find your median of the entire set of data, and that gets plotted. So you have 3 points at this point in time. Then what you're going to do is you're going to take, once you find your median, you have split your data in half. So you're going to take the first half of your data and find that median, and that goes right here. And then you're going to take the second half of the data and find the median, and that's going to go right here. And what this does is, notice we have what we call the lower quartile, because we've split this graph up into 4 pieces. You have 1 piece, 2 piece, 3 piece, and 4 pieces. So this is our lower quartile, this is our upper quartile, and again we have the median here. So at a quick glance, you can see that your data is spread from, it looks like we're looking at players' weights. So I would say maybe around 160, 170 pounds, and our data is going to go all the way up to a little over 300 pounds. Okay, but a majority of my weight is going to kind of fall in maybe like the 195 to 245 range, because this is where a majority of my data falls. This right here, I would consider that like an outlier. Likewise, so is this. Okay, and then you can see like kind of how things land in between. This is just another quick picture. Your minimums sometimes might be referred to as like a lower extreme, likewise your upper might be the upper extreme. Again, we have our lower quartiles, upper quartiles, and that median right there in the middle. So if we look at an example here, it says we have a box and whisker plot that shows the heights of boys and girls in school. Okay, and it looks like we have some questions here, and we have to find out which one best goes with this set of data. So it says the minimum height of boys is equal to the minimum height of girls. Well, if I look at my minimum height of boys, that's going to be this point right here, and the minimum point of girls is right there. So I'm going to say that that probably is not true. For part B, it says the minimum height of girls is fairly close to the maximum height of boys. So again, we have our minimum height of girls and our maximum height of boys. That is not true. Part C says the maximum height of girls, which is right here, is fairly close to the maximum height of boys. I would say that that probably isn't too far off, but let's just make sure that D is not an option. So D says 75% of the girls are taller than the shortest boy. Well, if this is broken up into quartiles or quarters, 75% would be this region right here. And would we say that 75% of the girls are taller than the shortest boy, and the shortest boy would be right here? I would say probably not. So it looks like C is going to be your best answer. Now for this box and whisker plot, it says the table shows the number of coins collected by 5 students, and we're given 4 different plots. So to figure out which one could be a possibility, what I'm going to do is I'm going to arrange my data, which is right here, in order from least to greatest, just to start out by finding the median, because I can see that I have different medians in these graphs all around here. So if I order them from least to greatest, I have 10, 16, 16, 18, and 20. And I can see that 16 is going to be my median. So that means I can get rid of the possibilities of plot number 2. This is not the box and whisker plot for that. Plot 1 stands a chance because it looks like the median is at 16, so I would say that this could be. Plot number 3, and remember the median is coming from, and I'll highlight this here, the median is that middle dot. So if I look at these right here, I can see plot 3 isn't going to work, plot 2 didn't work, and plot 4 did not work. So with that being said, it looks like plot number 1 is my best option for the graph of this data. Now I can also do some more investigation and look. Okay, if I look at my min and max values, I see that I have a minimum of 10 and a max of 20, which kind of coincides with what I have up here. So without knowing what the actual question was, I would say that plot 1 probably stands the best chance at being the box and whisker for this set of data. Now our last example here says we have a box and whisker plot that shows weekly practice hours of 2 different teams. So if we read through this, it says the average median practice hours for team B is greater than team A. I would say that that is not true because if I look at the medians, those are going to be right here and they look to be about the same. Average median practice hours are the same for both teams. That has some possibility. The upper quartile for team A is less than the median of team B. Well, the medians we just said were about the same, so I know that's not true. And then D says the average median practice hours for team A is greater than that of team B. And again, they're pretty much the same, so that's not true. So our correct answer then would probably be B in this case. Please let me know if you have any questions. Otherwise, I will see you in class. Have a great day.